Alright then. I'll just make sure everything is working fine. Okay, seems like so. Well, so let's first of all create a new project in Unity. So we have to give it a name. Oh, actually, yeah, that's better. Oh, that's a nice effect. Actually, this is really confusing. Wait, can I do that? So let's give it a name. We're gonna call it 2D platformer in my case, and we choose a template of it to be just a simple 2D game without any additional stuff. This is the place, the location of the files, and here we can add any assets if you want, but we won't need any of them. We will create everything from scratch. So now the project's going to be creating. It takes a moment. And here we are. So first of all, yes, I'm gonna change to default layout, so everybody's Unity will look just the same, because you can rearrange these, like everything you can pretty much rearrange anywhere you like. But we can just go with the basic one that is provided at the first view of the game engine. So I guess we could look around how the whole user interface looks like. Here we have the hierarchy, so every single game object that we have in the scene, we have them over here on the left. Down on the bottom we have all the assets and every file, scripts, materials, textures, everything we will need to add to the game. We have two options over here. The scene, actually three of them, but we're gonna cover just two of them. The scene, which we will use to rearrange things inside of the game, like move things around, move some platforms around, set them up. The game, which is like a preview of what the player can see right now, and the asset store, which we won't cover right now. To the right we have the inspector, which is a tab which will be needed if we click on any kind of an object. It shows some information about the current chosen object. We will be using this a lot. Basically, it's used every moment actually. Okay, so first of all, we want to create a 2D game, but we need some kind of sprites to add to the game. If we have some graphics, we can just add them right away, or we can just use some kind of 3D objects to use them instead. So what we have to do, make a right click on the hierarchy, press 2D object, and choose a cube. If we do that, we can see it is over here. If we zoom enough, we're gonna see, if we press over here, direct tool or T shortcut, then we're gonna see a cube which is created. If we change the size of it, we can see under the transform component, we're gonna see everything change, like the position, the rotation, the scale. Everything is always updated in real time. Just give me a second. And so we can add any kind of new components over here if we wanted to, like there is quite a lot, like physics and stuff. Basically, we will be using this, as I said, the inspector tab is used like very often. So what we first need to do, let's make a platform for the player. So first of all, we're gonna add the cube, then we're gonna right click on transform and reset. This will make sure that we have the position right under 0, the scale just at the exact 111, and then we can just rearrange it if we wanted to. So this is our platform. The player will move around on this platform. So let's just make it bigger. Like over here, we can just drag it, or we can just change it manually by changing the scale, like to 10. And then we can just put it into the middle by pressing 0 over here. So this is our platform for the player. Now we will need the player himself, right? So what we have to do is, as I said before, we can use a sprite, which is basically just some kind of graphic made by yourself or imported from somewhere. We will cover importing in later episodes. But for now, we can just use a capsule. Let's create a capsule over here. You can just drag it a little bit up. Leave the scales like that. And what we have here, this is a physics object, physics component, a capsule collider. This will make sure that we cannot hit, we can hit another object and collide with it. So if we press this, actually it's not going to fall because it doesn't have any kind of physics of sort of the gravity, for example. So right now they are just floating in air, but we can add a rigid body, which is a simulation of gravity and mass and drags, etc. Then the object will move around, will rotate, and will basically just fall down in this case. But this is a 2D game, so we want to use 2D physics. So we're gonna type down rigid body, and now we have rigid body and rigid body 2D. And because we want to create a 2D game, we're gonna choose a rigid body 2D. First we have to remove the collider because this is a 3D collider. And now we're gonna add rigid body 2D. And now we're gonna use a 2D capsule collider. Capsule collider 2D. Because then these two components won't bite each other out. Now if we hit play, it's gonna probably fall. Yes, it's falling right now. And because the cube itself is also a box collider, not a box collider 2D, it won't stop the player from falling down. So if we change it, remove component, like press the tool here, remove component, and add a box collider 2D, then the player should hit and not fall. As you can see, he just fell down and stopped on the platform. Perfect. So let's create a script for now which will handle the player movement. So we click on the assets tab under the project tab, press right click, create, and a C# script. We can call it movement. Now we're going to open it up in a program. I have a Visual Studio 2017. You can use basically any interpreter that you want. It's basically up to you. So usually, always, Unity starts with a basic script that includes a class of the name that we created. which derives from mono behavior, which is like a lot of functions, classes, and basically the whole Unity is built on mono behavior. Now we have two functions, a void start and a void update, and these two functions, as said in this comment, you can use this for initialization. So whenever the game starts and this script is loaded, it's gonna run every single line underneath this function. And update is called once per frame. So it's basically every time your game refreshes, a hard word, it's gonna run this script, right? This code. So this is like continuous, and this is just like one time. Okay, so above these two functions, we're gonna include our rigid body 2D for the player, because we're gonna be using it. So let's write down public, and we're gonna write down public because if we have the public state, then in Unity we're gonna see under the script, if the script is added to the player, we're gonna see it as a component, and then we can just drag and drop the rigid body onto the script. You're gonna see it in a moment, just trust my word. So public rigid body 2D, and let's just call it RB. Second of all, we're gonna need a public float. We can name it move speed. Then we're gonna need another float of type of name jump height. Yeah, I think that's it. We're gonna see. So under the update function, we're gonna see if, as I said, this is called every single frame, so we can check if the player holds any kind of a button, for example. So yeah, let's just do that. So for this, we're gonna be using a function, a statement if. Then we're gonna check from the class input dot get key. So every single time some kind of a key is held, it's gonna be included into this if it's gonna be true. So what type of a key? We need to type what key. So let's type down key code dot, and then let's go with an A, because we're gonna be using A and D to move left and right, and a spacebar to jump. For example, you can just choose whatever you want, like arrows, I guess. So in case someone presses A, we want to increase the velocity of our player. So we're gonna be using the rigid body 2D component, as in RB dot velocity, and we're gonna be setting it to a new vector. Vector 2 is basically yeah, as it said, representation of 2D vectors and points. It just holds two variables of type float. So a new vector, which is so first of all, we're gonna put down the x value and then the y value. So if this is our x and we're moving to the left, as in a button moves to the left. Hello, Hossein. Then we're gonna type down the move speed, which is multiplied by a specific time value, time dot delta time, which is basically the calculation of the time between the last update and the current one that happened the most recently. And the y value is going to be the same that it is right now. So rb dot velocity dot y, because when moving horizontally we don't want to change our height velocity, sorry, vertical velocity. And my bad, if we are moving to the left, we're going to have the negative move speed, not the yeah, minus move speed, not the plus move speed, basically. So another case, so if not moving to the left, then it's gonna be checking if he is moving to the right. So else if, and then again input dot get key, and then key code dot d. So this is when he is moving to the right. So again, rb.velocity is a new vector 2 because it's a 2D game. We're gonna have move speed, not the negative one, because we're moving to the right. Again, times time.delta time. And not changing the vertical velocity. So this is only a good practice over here. So if neither A or D button are pressed, we want to set down the velocity to 0 so the player stops. So rb.velocity equals new vector 2, and again instead of putting down the move speed, we're gonna just say 0f and not change the velocity of the y axis. So now we need to just save, so press the Ctrl S to save. We're gonna go back to Unity, give it a little time to compile everything. It's just loading over here. And we should be able to, oh sorry, my bad, we have to first add this component, this script, into our player. So we can just open the capsule, which is our player, and move the script from here to the right. Now we have to add the rigid body 2D to our script, so we can drag it from here straight down to RB. Then the move speed, we're gonna have to set it up. We can basically set it up right now and have the changes saved every time, or we can just change it at runtime, but everything we change during the game, the settings will just go back to default. So let's say how much would be fine. Let's start with 100 maybe, and the jump height should be it's not gonna be defined right now. Yeah, we are not using it right now, so let's just leave it with 0. And let's see, we can actually move to the left and to the right, which right now is pretty clumsy because we still have the rotation on for the player, but basically it works. And as I said, if we change the value right now, so we can go from the game to the scene, we can press the capsule, and then we can change the move speed at runtime, like go to 200 and see the difference back into game, and we're double the fast. And yes, this can also work, but yeah, if we stop the game right now, the changes went back to 100. Okay, so let's leave it at maybe 300 should be fine in this case. So the second thing we need to do is to block the rotation of our player so he doesn't fall to the side like he did just a second ago. So under rigid body 2D, under constraints, we can open it up, and we need to freeze the rotation on the z-axis. This will make sure he won't fall, like so. Okay, now let's create jumping, because every player likes to jump. So again, we have the jump height, we have the move speed, we have the RB. Okay, then let's create another if. So if input dot get key, and then a key code dot, for example, space or a W or the up arrow, as you wish. In this case, we need to add him some velocity on the y-axis and not change the x-axis velocity. So rb.velocity equals new vector2, leave the x velocity as it was, so rb.velocity.x, comma, jump height. That's basically it. Now there's a little flaw with this code. We can just save it and we're gonna see it in the game. We're gonna change the jump height to, like, I don't know, 5. Let's start with 5. We're gonna see. And right now we can jump, but what we can do is actually jump as much as we like, because there is nothing stopping the player from jumping another time while he's in the air. So let's go back to the script. And make a true-false statement, which is a boolean, of course. We can leave it in private, so private bool jumping maybe. And so if he jumps, we're gonna set jumping to true, because the player is jumping. And now we have another function that can check if our player is colliding with another collider, which is called void on collision not detection, but enter 2D. And then in the parameters we have to add collision 2D and just name it call, for example. So in this case, the player will detect every time the player detects some kind of collision, the information about the collider that we have collided with will be entered within this call parameter. So what we want to do is use Unity tags, which are over here. If we go back to Unity, press on the player, so the capsule, up just below the name of it, which we can actually change to player. The tags. There is a tag for player over here, and then we can create a custom one for the cube. Pressing on the cube, going to tag, we can add tag. There is a list of tags. Add a new one and name it, for example, platform, and save it. So now our cube can be changed. Our cube's tag can be changed to the platform. So we can right now compare the tags. If the player fell down and collided with something, we can change. We can check if this was if it was the platform, because if it was, then the player can jump again, right? Makes sense. So let's write down if call dot game object, because we need to access the game object itself from the collision. The game object is over here. Then from the game object we can go to .tag and check if it equals, so double equals platform. Okay, so if it is the platform, then we want to set the jumping to false, because we are no longer jumping, because we have entered the collision with the platform. So basically we can't jump, right? Makes sense. So jumping equals false. Now to make all of this work, we have to go to the if statement for our jumping and add another another if. So if the player presses space, and also, which is a logic value, and using these two, and the jumping is false, then we can jump. In other case, we cannot. So let's see. Let's save this and go back to Unity. Save this as well and hit play. So right now, if we press the spacebar a lot, we can jump, but only if we hit the platform before. There's just no other option, and we can just move around and jump at the same time. And we are stopping right away if none of the button A or D is held. Which is very simple and very good for starting games in 2D, in Unity, movement script. So, yes. What else? We could also add a crouching. Yeah, let's create crouching. So if the player holds down the S button, in my case, or the down arrow if you want, then the player will crouch. Crouching will mean that the player will shrink, basically. So if input.getKey keycode.s, in my case, then we want to change our player's local scale, which is rb.gameObject.low. Wait, where was wasn't transform? Sorry, rb.transform.local scale, and we need to set down a new vector for it. So equals vector3, because every object in the game has a vector3 scale, because it has also the x as well as x and a y and z axes. So a new vector3, and then change the scale from 1, which is the default value, to, let's say, 0.7 maybe, f. So you add f whenever you are using floats in Unity C#. So this is our x, this is our y as well, 0.7 f, and our z just for good measure. And if we are going to use some kind of texture and material for the player, we want to shrink it equally on every axis so that the texture doesn't start working very strangely. Okay, so if this is held, then we want the scale to go down to 0.7 float. So in another case, but we're gonna not specify it. So like in every single frame, if the player doesn't hold down the S button, we want the scale to be the default value, which is 1, right? So rb.transform.local scale equals new vector 3 and 1f, 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 which is going to set down back to the default value. Now going back to Unity again. Just wait a second if it compiles. And now it should work. So if I hold down the S button, it's going to be shrinking, and we can also jump and move around. And if you go back and not hold the button, then we're going to go back to the big size, like the default size. So another thing we could do, right now our gravity gravitation is multiplied by the player's mace, which is 1, and we can change it to be different whenever he's crouching, right? So he doesn't jump up so high. So whenever he is smaller, which is over here, we can also change the rb.mace and set it to, let's say, 5 instead of 1, and then also go back over here. So in case the player doesn't hold the button and he is in his normal size, we have to change the mace back to the default value, which is gonna be 1f. You can also go back here to check this compiles, and let's hit play. So right now if we jump, we're gonna be jumping like that, and if I'm gonna shrink it, then we are jumping probably a little bit less, or at least we should be, because this is how gravity in this game should work. Okay, alright, another thing we could add is some lighting. Because we are using 3D objects over here in our 2D game, we can also mix these two. Unity provides that. We can uncheck this top button over here from 2D to a 3D view. Go over to the Z-axis and see the player being actually a 3D object. So we can add some lighting to make this game look a bit warmer, I guess. So let's hit right click over here in the hierarchy, check the light, go to directional light, which is the imitation of a sun. If we hit it from here, the shadows are gonna go the way these shafts are showing. We can always rotate that using this button over here. This will pop up our rotation option, so we can change the shadow shafts. And for me, I wanted the light to be actually directional, mostly to the front. So now if we hit play, the lights are there. The player is actually lighted. We can see the shadows of it as well. And everything looks just a little bit better. If you also want, we can move this camera a bit up. And there is also the projection option, which can choose between the orthographic, which is really good for 2D games, and if you want to create like a 2.5D, which is, you know, a 2D platformer but using 3D objects, you can change the camera type to perspective, and then in the game tab we can see this is actually 3D, right? So here play, we can also see the shadows. We cannot because it's a little bit like behind it. Let's see if we can move this around a bit. and rotate the light. This is not casting shadows. Oh yeah, probably because the collider is no, this is yeah, this should cast shadows. Okay, I'm gonna see it actually in the another episode because for some reason this shadow should be casted. And it's not. Maybe because it's using the 2D colliders, both the capsule and the cube over here. But it's not very important right now. So yeah, this is the basic script for movement. It's fairly simple, but also it is very like in my opinion, it is one of the best for starters because it's customizable. You can change the speed and everything. It doesn't take a lot of physics to understand it. Yeah, and basically you can use it to create your first pretty good game. You know, I believe in you. Okay, I'm just gonna set my camera back to orthographic. And this is where we're gonna be leaving this episode. In the next episode, we're gonna make the camera follow the player and add some new features like maybe some kind of score. Tune in to the next episode of the C# Unity webinars. Goodbye.